there? Once we got the thumbs up from you, Miss Morrissey.
Yeah.
We're on? Yeah?
Yeah.
Superb. Good afternoon, Year 11 for the final time. Paper 3, Geography Booster. You can see there it says fieldwork only. I'll only be going through the fieldwork today as we're not allowed to do the pre-release because it's use a third right copy and all that sort of stuff. However, I'll crack on, and if you have any further questions, please don't hesitate to pop them in the comment box that Miss Morris is manning. Just a quick reminder, tomorrow morning all teachers will be available from 8 AM. Feel free to come to our classrooms, ask us any questions to do with either the pre-release or the fieldwork, and we can give you a little bit of help there. Right, let's get started. To begin with then, you are going to have familiar fieldwork exam questions. What that means is we have done 2 fieldwork studies. We have gone to Mappleton and we have gone to Barnsley. You could be examined on any of the following: collecting data methods, the presentation methods, the results of our study, the conclusion and the evaluation, so maybe perhaps how we could have improved our study. All the questions could be on a combination of any of these 5 sections. I'm quickly going to run over today exactly what each of these 5 different sections entails for both the physical and the human fieldwork. I'm also going to present you with a few perfect answers that you can perhaps look at and maybe use tomorrow if similar questions appear. But first of all, let's go on with that physical fieldwork element. And Mappleton. We could have taken you to the rainforest. We could have taken you to Australia to look at a desert. However, we didn't. We actually went to Mappleton along the Holderness coastline. The Holderness coastline runs from here, from Flamborough Head, all the way down to Spurn Point, of a distance of about 70 miles. Now, we went there because it links to the course perfectly. You are aware that this area here is the fastest eroding coastline in Europe. And it also has hard engineering in place, specifically at Mappleton where we decided to go for our fieldwork, which develops the question: assess whether hard engineering methods have been effective in protecting the coastline at Mappleton. You need to know this for tomorrow, ladies and gents. This is the one question that we 100% can confidently put £1,050 on. We know that that question is going to appear in the exam. However, you won't be marked on it. You need to put that question in the exam so the examiner knows exactly what fieldwork you did. If you imagine every single person in the country is going to get the exact same paper, that paper could be delivered anywhere. You need to inform the examiner before you even start answering any questions what that is. And there is a place available which says, please write down the inquiry question of your physical fieldwork here. You need to write in that, and it will appear on every single slide for the first half of this show. So Mappleton, picking a suitable question. First of all, Mappleton's positioned along the Holderness coastline, 5 miles south of Hornsea. A little bit of direction for you there. Hornsea's here, Mappleton is just 5 miles south there. We know it's the fastest eroding coastline in Europe, with over 2 metres of land being lost a year. That is significant. If we look at this map here, which shows you the geology of the Holderness coastline, it's predominantly made of boulder clay. So when the waves are constantly attacking this coastline here, some of that boulder clay is eroding, which is quite dangerous. On this photograph, you can actually see the extent of that erosion there. And look at that road. That road used to actually run along the coastline, but due to this coastal erosion, these waves constantly battering the coastline, it's actually eroded, started going into the sea, which isn't very good at all. So the main road, not this one, I'm talking about the main one that's all the way back there that you can't see on the photo, that is now at risk of falling into the sea, because if this starts to erode more, that main road that you use to access Mappleton is going to be cut off. So to stop it happening, what they've done at Mappleton is they've actually put in place a series of hard engineering techniques. They've got a groin, they've got 2 groins, and then they've got lots of riprap based at the bottom of the cliff. Finally, it's only 2 hours from school, Mappleton, so this made this question absolutely perfect for us to do, which is what presents this question then. A classic exam question that might come up. Explain why the chosen location was suitable. You've got loads of reasons you can talk about. First of all, erosion is happening rapidly there. First point. Or hard engineering has been put in place. We can assess whether or not it's working. And finally, it's only a 2-hour journey from school, which makes it a suitable location for our study. The next part of the fieldwork, you need to know the risks. Again, you can see the question which is going to remain there for the entire presentation for this first half. The physical fieldwork risk assessment. You need to know when you do a piece of fieldwork, what risks could actually exist when you go. And you can see there, flashing is danger, danger, danger. Danger, falling down a ramp. Danger, cutting yourself on a rock. Danger, drowning in the sea. You need to be aware of what risks exist, who is at risk, and what precautions we can take. So the first one, identify that hazard. Second one, who might be at risk. And the third one, precautions we might take to prevent that risk from happening. And I've got an example here. When we went to Mapleton to transport, what was the hazard? Crashing. Quite easily, we might crash. Who would be at risk? Students, staff, other road users. And finally, what did we need to prevent that from happening? We used the qualified driver and we made sure we wore our seatbelt. Dead straightforward. Another one you might talk about is that weather. What was the hazard? Sunburn, overheating. Who would be at risk? Students and staff. And finally, the precaution taken, appropriate clothing, shorts, t-shirts if it's warm, and applying sun lotion there so we're nice and protected. Then we get onto the nitty-gritty of it. Now this is where it starts to become a little bit more difficult. For the physical fieldwork, title's up there, you had to collect different types of data, and you need to be aware that what different types of data exist out there. First of all, you've got primary data. That is data collected by yourself. Then you have secondary data. That's collected by somebody else, and you might access that online, in a newspaper, or other sources like a magazine. You do not collect secondary data yourself. Anything that you have learnt that you haven't collected yourself is secondary data. Then we've got quantitative data. Quantitative data, this is all to do with numbers, statistics, anything which you can quantify. However, qualitative data, that is simply descriptive. So you need to be aware of different types of data that you can actually collect when we go out in the field. Now, I know we didn't do all of these, but you need to be aware of a range of them. So types of data. First of all, this is what we call a questionnaire, where you ask people questions. This is primary because you would be asking the questions. It could be qualitative because it could be to do with numbers, words, and description, or it could be quantitative. How many times have you visited this shop today? Twice. Researching land use. That is simply going out into the field or looking online. What is the main use of land on that street? Is it housing? Is it shops? Is it recreational? So that would be secondary data because you're collecting it online and it's descriptive, so it's qualitative. The bipolar survey or the environmental quality survey, which we did, that is primary because we're collecting it ourselves, and quantitative, you can see numbers there to make it quantifiable. Counting footfall, again, we would do that, so that would be primary. And then it's quantitative data again because it's numerical. Taking photos, again, imagine if that's you, you're taking them, primary data. Qualitative because it's certainly not numbers, but it would be more descriptive once you analyse them. And finally, collecting photographs there, that would be secondary, qualitative too. Now, if we had a question, let's say, assess whether hard engineering methods have been successful in protecting the coastline at Mapleton, how on earth are we going to answer that question? What we would need to do is pick suitable data collection methods to make sure we can find out the answer to that question up there. So what we decided to do is we decided to 1, measure the speed of longshore drift. We decided to 2, calculate the beach gradient. And number 3, we decided to calculate the cliff height. First of all, you need to know how each of these methods work. Then, why on earth we decided to do these. You need to justify exactly what on earth was the point in measuring the speed of longshore drift. First of all, we measured out 10 metres running parallel to the beach using a tape measure. We then placed the float in the water at one end of the 10 metres. We then used a stopwatch to time how long it took the float to travel 10 metres. We repeated this 3 times. Finally, we then took an average after we'd done it the 3 times to get the speed of longshore drift. Why on earth did we do that? Well, allows us to time the speed of longshore drift and the rate that material is transferred. We know that if longshore drift was very, very quick, that means that erosion was happening. But if it was very, very slow, that means that erosion wasn't happening as much. Therefore, if it was slow, the hard engineering must have been working. This is what it looked like in photographs. We measured 10 metres out along the beach. We then threw a float in the water. Please don't say orange, although you can, but float's better. We placed a float in the water and then we timed it, how long it took to travel 10 metres, and repeated it 3 times. Next one, calculating the beach gradient. How on earth did we do it? This one's a little bit more complicated. We placed a ranging pole where the waves break. This tall thing here, that is a ranging pole. This area is roughly where the waves break. We got as close to the breakwater point as possible, where the waves break. We then placed a second ranging pole where we thought the beach gradient changed. You can see here, we felt that the beach gradient changed between these 2 points, therefore placed it there. We then measured the distance between these 2 points. You can see me doing it there with the trundle wheel. And we repeated it until we got to the cliff. I missed that bit out, sorry. We measured then the angle between the 2 points as well. And again, I'm going to show you that in photos in a second. Why on earth did we do that? What was the point? We knew that if there was a bigger beach gradient, more sand, on the beach, that meant that hard engineering was in fact working. But if there was hardly any sand on the beach, that would suggest that hard engineering wasn't working. And that is why we measured the beach gradient. Here it is in photos. We placed that ranging pole where as close to the breakwater zone as that we could without going in. We then placed a second ranging pole where we thought the gradient, this is the gradient ladies and gents, how steep you think it is, and then it might change somewhere. We placed a ranging pole where we thought the gradient changed. We then measured the distance between them before measuring the angle between them. That was the crucial part. We then repeated this all the way until we got to the back of the beach, and that provided with us some data that we could then later graph when we got back to the classroom. Finally, we also calculated the cliff height. When we calculated the cliff height, it was used similar equipment to the beach gradient, but it was slightly different. With the cliff height, what we did is we measured 20 metres out from the base of the cliff. So if this was the cliff here, this is the cliff, high cliff. There might have been this was where the bus was parked, if you remember. There's a bus there. We measured 20 metres out from the base of the cliff, and we then measured the angle of the cliff like that, dead straight forward, using the clinometer. Later on then we could use trigonometry to work out this angle, which then would then work out this height, because we know that that there is 20 metres. Now what on earth was the point in that? Let me draw another sketch. North of the groin, imagine if hard engineering was working. If hard engineering was working north of the groin, we would expect there to be a larger buildup of sand. If the hard engineering wasn't working, we would expect there to be hardly any sand. And this is where it becomes easy to work out. We measured the beach gradient on the north side and the south side. Notice how the cliff is the same height on both sides. The only difference is, on this example, on example A, we're much higher up. We're closer to the top of the cliff because there's more sand. Therefore, measuring the cliff height indicated to us whether or not hard engineering was working. The smaller the cliff seemed, the less erosion there was. the taller the cliff seemed, the more erosion there was. We need to also know different types of sampling. When we went to Mappleton, what exactly did we do? Did we just start randomly measuring longshore drift wherever we felt was the best place? If we did that, that would mean that members of a population or a location would have an equal chance of being selected. We did not do that. That shouldn't say secondary data, sorry, that should say systematic. I've copied that over wrong. The second one is systematic data. That would be quite hard to do on a beach, but if we were talking about human geography, what we could do there is we could take a sample of a population proportional to its actual size. And an example here, if I wanted to ask everybody in school what their favourite chocolate bar was, 2,000 students is going to take me a long time. It would make sense to ask 10 students from each year group, which would be proportional to the actual size of the school. Finally, systematic sampling. That is data collected at fixed intervals. So instead of just doing it randomly, every 10 metres or so, or every 50 metres, we would collect the data. And this is the exact thing that we did. We collected longshore drift every 50 metres, and we did the beach gradient every 50 metres, therefore representing a perfect area for our fieldwork site. You might be asked this question. Dead easy, 3 marks. Justify one primary data collection you used in your physical geography inquiry. You could talk about any of these 3. You would say, we measured the speed of longshore drift, nice and easy. We measured out 10 metres along the beach and we timed how long it took a float to travel. We did this because if longshore drift was fast, that would indicate that hard engineering wasn't working. If it was slow, it would indicate that hard engineering was working. And it would be the same answer for the other 2 with their respective techniques in place. Presenting our data. All of a sudden we're now back in school and we've got a lovely bank of data with us that we can now do something with. As well as presenting our data, you need to be aware of all different ways that we can present data just in general in geography. Here we've got a radar graph, which I'll come to a little bit later. Here we have a line graph which represents change over time. You can see Monday, Tuesday, Wednesday, Thursday, Friday and how the temperature is changing over time. This is a pie chart which often represents a percentage of 100. We've got a choropleth map here where you can see extremities where maybe there's certain hot spots for either crime, weather. Finally, we have a bar graph before finishing there with a scatter graph. Now a scatter graph is really good because we can see the relationship between 2 independent variables. You can see all the data that's plotted on here and a line of best fit has been placed through the centre of it. If you are asked to do a line of best fit, it needs to go through as many of the points as possible, but it needs to be a straight line. And of course there will be points that it misses because you are going in the general direction. This scatter graph happens to have a positive correlation. How did we present our data then? A little bit different to what we've just seen then. We presented it on a map showing the speed of longshore drift. Why on earth did we present our data this way? What was the good thing about presenting data that way? Well, dead straightforward here, it says it allows you to see where longshore drift is fast and therefore where erosion is the greatest. Pretty simple, pretty straightforward. However, it doesn't actually show you the conditions of the day, so it's difficult to pick out anomalies within that data presentation method. We then looked at the beach gradients. Look at them. You can see when I'm going to blow these up slightly larger shortly. Now, an advantage of this is that we could visually see where more sediment had been accumulated. So we could then draw a conclusion. You can see there, on this one here, there's clearly more sediment. Therefore, it must be working here, hard engineering, and not much of it working there. However, a bad thing about this is it doesn't indicate whether the sediment there has been naturally built up or artificial. Imagine if it was put there by soft engineering. It wasn't, but imagine if it was. From that data presentation method, we can't see that. The cliff height graph, absolutely superb because we can easily see which cliff is taller and then conclusions drawn. However, a cliff graph is pretty difficult to interpret. And imagine if you thought that a smaller cliff meant that more erosion had taken place. How silly would that be? Ha 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 ha. We taught you that wasn't the case, but imagine if you had. That would be a negative of using this as a data presentation method. Analysing our data then. Now go back to this question at the top. Physical fieldwork. Assess whether hard engineering methods have been successful in protecting the coastline at Mappleton. From our longshore drift map, quite clearly we can see that it was only going at 0.3 metres per second north of the groin. But south of the groin it was going much quicker at 0.5 metres per second. That suggests that this groin and the riprap, which I haven't put on here, is actually protecting the coastline north of the groin, and longshore drift is slower, therefore erosion is slower. Yippee, it's actually working, that's superb. But on the south side, longshore drift is much, much quicker. That may therefore mean there's more erosion, and therefore hard engineering is not working. If you can remember those figures, you are going to be on the money for doing very, very well. If you can't remember those figures, even if you said it was 3 miles an hour north of the groin or 5 miles an hour south of the groin, that's still going to get you some marks. And if you can't remember that, all you need to remember is that it was certainly slower north of the groin and much faster south of the groin. Whatever you do, I know I've asked you I've suggested that you'll be able to make up data in the past. You can do here 3 and 5. However, please don't say it's 300 miles an hour on the north side and 500 miles an hour on the south side. That's clearly not correct. Our beach gradients. We collected our data and we've presented it using these beach profiles. Now look at this. Check it out. We have a much larger beach gradient on the north side of the groin. You can see it extends not from 0 to 5, but to 0 to probably there about 37 metres. This beach is 37 metres long and it's got a much larger gradient than the south side. On the south side, it only extends to about 26 metres, and you can see it's a much shallower gradient. What does this tell us in terms of our answer? Is hard engineering working? On the north side, quite clearly, that should end for north, that north, yes it is, because the beach is longer, up to 37 metres, and it has a much more gradually increasing gradient. However, on the south side, the length of the beach is much shorter, only 26 metres long, and the gradient is much more shallow, suggesting that more material has been eroded and that hard engineering isn't working. Finally, oh sorry, I've got a good photo for you here. You can see the different beach profiles now. If this was the groin, we parked up here if you remember. If this was the groin, this was the north side of the beach, and quite clearly you can see the north side compared to the south there is much, much larger, because this groin is stopping longshore drift, therefore preventing erosion, therefore on the beach, on the cliff here, you can see actually grass has started to grow, suggesting it's protected, suggesting that the groin and the riprap is working. However, on the south side, the beach gradient is much shorter, it's much shallower, and that's because erosion is taking place and it's not protected. If we went even further south, you'd see those clay cliffs exposed. Cliff height graphs, our final data presentation method. The cliff height on the north side is much smaller than the cliff height on the south side. That suggests that more material has been eroded on the south side, and therefore we are technically stood lower down, making the cliff height seem higher up. On the north side, however, there is more material, so the cliff height seems taller at 9.3 metres. Therefore, less erosion has happened, more sediment has built up, and hard engineering is working on the north, but not working on the south. Linking our data collection methods. This is the best bit because, look at that. Longshore drift is slow, so hard engineering is working. The beach profile is long and big, therefore hard engineering is working. The cliff height on the north side is smaller, suggesting a larger buildup of sediment, therefore hard engineering is working. However, on the other side, on the south side, longshore drift is much quicker, the beach profile is much smaller and shorter, and finally the cliff height is much taller, suggesting a greater rate of erosion. Therefore, hard engineering isn't working. And that, ladies and gents, is the link between our data. What was the conclusion of our fieldwork? I've been saying it all along. Dead straightforward. Hard engineering, success north of the beach, failure south of the beach. If you can remember those speeds of longshore drift at 0.3, at 0.5, you are going to be on the money for doing really, really well, because it will make you look like you fully understand your study and the technicalities behind it. Last bit on the physical fieldwork. How might our data collection have produced unreliable results? Well, when measuring the speed of longshore drift, what could have gone wrong? You are all really, really good at doing this bit. We may have used the timer incorrectly, so timed incorrectly. We may have measured out the 10 meters wrong, measured out 10 meters wrong. We might have a different person throwing the float in would have produced inconsistent results. So how could we improve it? Well, we could have gone back and we could have done it 4 times across the year. We could have made sure that we taught people how to use the tape measure and made sure that 3 people used the timer and took an average of that. Calculating the beach gradient, what could have gone wrong? We could have used the clinometer incorrectly. Quite easy to do that one. So how would we get over it? Using an electronic clinometer, that would have been more accurate to make our results more reliable. And finally, with the cliff height, very similar, the clinometer. If you can talk about that, again, you're going to be on the money because you know what could have gone wrong, but then also how we could have improved it. Having said that, we did do longshore drift 3 times. That suggests it was fairly accurate. I'm going to have a quick drink before I go through a couple of exam questions with you, and then we will go through the human fieldwork. Shout out to our 8 viewers. Hello. That makes it sound really unpopular, but we are aware that lots of people like to play this back. 21 playbacks so far. Right, okay, let's crack on. How to answer the fieldwork questions in paper 3. There are very, very few questions they're going to ask you to do the fieldwork that you know. It's going to link back to that collection, presentation, results conclusion, or evaluation. To do well, you simply just need to learn how to structure your response to a specific question. For example, let's look at this one together. Assess the effectiveness of your data collection methods. Now, in all of these questions, you're pretty much going to be given 2 sides of an argument. For an assess question, you need to give 2 sides. What are then the 2 sides to this? Whether it's going to be how it is effective, that'll be one side, and then how it isn't effective. That's going to be your 2 sides to the argument, how it is and how it isn't effective. Then you need to pick a data collection or collection methods and then discuss them. Were your collection methods effective? What was good about them, but also what was ineffective about them? And I've got a perfect example for you here. One way in which we collected our data at Mapleton was measuring the speed of longshore drift. Here you go, 1 mark already because you've named a method of data collection. This was effective because we measured 10 metres along a beach using a tape measure and timed how long it took the float to travel 10 metres using a stopwatch. This is effective because longshore drift was fast. This would mean that hard engineering wasn't working. However, if it was slow, it would mean that it was working. This data would indicate that the collection techniques were effective. Furthermore, when collecting our data, we use systematic sampling. If you can get this bit in, again, you're going to be massively on the money because very few people will include that, where we calculated the speed of longshore drift every 50 metres. This provided us with data that represented the entire beach. However, our data collection methods might have been, that should say ineffective. Apologies, ladies and gents. Ineffective because we may have measured out 10 metres incorrectly and stopped the stopwatch after the floats had passed. This would collect inaccurate data. On the other hand, we did measure the speed of longshore drift 3 times to improve the accuracy of this data collection method. In addition, historical photos of Mapleton, secondary data, would have been an effective data collection method technique to see change over time, which supports the primary data collection methods above. That seems very, very long, ladies and gents, but essentially what that is saying is, it is saying where it is effective, why ours was really effective, why it might have been ineffective, but then saying again, on the other hand, it was pretty effective overall. I will give you a summary sheet at the end of this on a slide, which you will be able to apply the summary sheet to that sort of question. The main thing you need to be aware of is when the question comes up, you know you are going to give 2 sides. You need to make sure that you are aware of a data collection method and why it was good and why it was bad. Next question. Assess how effective your presentation techniques were in representing the data collected in either your physical or human. I'm going to be doing physical here, but you could also apply the human knowledge a little bit later on. But again, effective, so it's going to be 2 sides. You're going to need to be doing one side to how it's effective, one side how it's ineffective, and I've got an example here for you. Here we go. Remember, this time it's presentation techniques, not collection. The cliff height graph. Notice how it says graph, because that's a presentation technique, is an effective technique as it was clear a visual representation of the cliff height. Dead straight forward. Why was it effective then? It enabled us to recognise that the north side of the groin had a smaller cliff, whereas the south side had a taller cliff. This is why it was an effective method. This suggests that hard engineering techniques were a success north, but a failure south. You guessed it. However, when calculating the angle of the cliff, we may have used trigonometry incorrectly. Imagine that. And produced a graph which illustrated the representative height inaccurately. Imagine if we had done trig completely wrong and the north side looked tall and the south side looked, the wrong way around, sorry. The north side looked tall and the south side looked small. Our data would all be all messed up. Furthermore, due to the difficulty of reading a graph, this may have been interpreted incorrectly when analysing the results. To reduce this error, we could have taken photographs in addition to support the cliff height graph to reduce error in humans' interpretation. Because if you had some photos next to you at the same time, you'd think, well, that graph doesn't match my photo, and you would know that your graph was wrong. Finally, last question that I'm going to go through for this first part. For one of your geographical studies, to what extent were the results helpful in reaching a reliable conclusion? One of the harder questions, because now you are combining 2 elements. You are combining the results and conclusion with the evaluation, even though the evaluation is not mentioned. What do you need to do for a what extent question? Two sides of the argument. What are they going to be? Why our results were reliable and that we could meet a conclusion, but also why they weren't reliable, so why we couldn't meet that conclusion correctly. Here's your example. Our results, let me just change my highlighter, sorry. Our results from the study suggested that hard engineering at Mappleton has been a success. So this is now saying, so our results have suggested that it has been a success north of the groin, but a failure south of the groin. You got a mark there straight away because you have told them your results. That's part of the question. It goes one better. It says that north of the groin it was travelling at 0.3 metres per second. The results from our beach gradient tell us that it is a longer beach with a steeper gradient. And but on the other hand, it's 0.5 metres per second south of the groin, and the beach gradient was shorter and shallower, indicating a greater rate of erosion. These results suggest that our aim was met. Those results there, ladies and gents, answer our question, answer our aim. Hard engineering is a success north, but not south. But remember, it's a to what extent question. You now need to think, what could have gone wrong? Imagine if our results were completely wrong, our aim wouldn't have been met. However, the validity of our conclusions could be, I know it wasn't, inaccurate due to human error and a small sample size when collecting our fieldwork data. For example, when measuring the speed of longshore drift, we may have measured distance longer than 10 metres, therefore calculated the speed incorrectly. This would have produced unreliable results when analysing our results. Therefore, our conclusions might not be valid and our aims not fully met. Here you have said why they were effective. Here you have said why they weren't effective. Moving on to the human fieldwork. All those questions which I've just gone through can be applied to the, they could ask you about the human or the fieldwork, or like that last question there, for one of your inquiries. So it's entirely up to you whether you want to talk about the physical or the human. Human fieldwork then. Barnsley. Again, same part. You need to know this question. Does Barnsley need regenerating? During the 1980s, Barnsley experienced a period of decline due to the coal mines closing. Everybody getting very, very annoyed at that. It therefore became forgotten about. Unemployment went up, shops became left vacant, nobody went to the town centre, and it became derelict. Not a very good thing at all. Meanwhile as well, it's got Leeds and Sheffield just to the north and south of it, pulling people away. The footfall then has become minimal in Barnsley town centre and it's in need of regeneration. Look at this, it's got a poor shopping choice. It's had limited availability of food and drink. You go into town, there's not really a great deal to do. Family opportunities are limited. Antisocial behaviour, that's people being silly and being abusive, disturbing maybe different people around there. Evidence of litter, expensive and difficult to maintain existing buildings. So people just don't really care about it. So what's actually changed recently? Barnsley's economy is actually growing. It's seen a 9 times greater growth than the employment, the regional average employment in the construction sector. Yorkshire and Humber attract 260 million visitors. So Yorkshire is becoming a really, really popular place for people to visit. And finally, its population is increasing. So with pretty much these two things combined, more people coming, it's a perfect opportunity to redevelop. Why was it suitable? Barnsley's experienced a period of decline due to the coal mines closing, creating unemployment. Footfall's low due to the two major cities, and finally, again, it's only a short distance from school, which made it a perfect place to go visit. Risk assessment, same thing again. We've got stages. Identify the hazard. Who's at risk? What we're going to do. We could have got lost by walking too far away from the designated area. Who might be at risk? Students. What did we do? We make sure you wore high-vis jackets to be easily identifiable. And all of you did that really, really well. We were very, very impressed. The weather and suitable clothing, same as before. It might have been raining though. The previous year actually it was snowing, so we had to call that trip off completely and reschedule it. But yeah, sunburn, overheating, students and staff, appropriate clothing, sun lotion if needed. Again, we've got our data collection methods. We could have done any of these. To find out, does Barnsley need regenerating, we could have done any of these data collection methods. We chose to do a bipolar survey and we chose to take photographs, How did we do this? Well, we decided on the criteria in the survey. You can see me outlining it there. Then we created an appropriate scale, one side which represents good, the other side which represents bad. Then we went to our fieldwork site and conducted it at specific locations. We did it at the first point and the middle point and the end point to get a fair representation, systematic sampling. Why did we do it? It allowed us to get a look and feel of the area. We then could make judgments about these different criteria, and we understood that if it had a low score, that meant the area was really, really bad. But if it had a high score, it meant the area was really, really nice. Taking photographs, what did we do? First of all, we decided on the purpose of the photo to represent the quality of the environment we were looking at. We then identified what area we wanted to do. We found a sheltered position and we simply took a photo. Why did we do it? Evidence. Evidence to come back to the classroom and say, this is what we found. Imagine if I went away to a different country that no one had been to before and I said, that was one of the cleanest countries I've ever visited in my entire life. Unless I showed you photographs, you wouldn't believe me. So it was simply to provide visual evidence. Sampling techniques, again, been through those. We use systematic sampling down here because it was data collected at fixed intervals to get a fair representation of the entire area. We didn't do it randomly, that would be silly. One primary method that we used, bipolar survey or photographs. We did a bipolar survey to understand a look and feel of the area. We knew that if it scored low, that was a poor quality environment. If it scored high, that was a good quality environment. Dead straightforward. You've told them how you've done it and you've told them why. How we presented our data. Using the data from our bipolar survey, we created this thing. It's called a radar graph. It's superb because it allows us to compare one or more groups of data. Look at that, site 1. At site 1 on here, apparently, according to this, it means that noise scored a 2, litter scored a 4, shop exteriors scored a 3, recreational opportunities a 2, etc. Here you can see they all consistently scored low on noise and poor on shop exterior. Greenery was actually pretty spread out and restaurants was pretty low also. However, they can become difficult to read. You can see there, it can get a little bit messy. Photograph annotations. Why was this a good way? Well, it allows you to illustrate specific findings of the area. We saw that consistently greenery, we couldn't see greenery in any of the photos, and some shop exteriors weren't very good at all. There was also chewing gum in a lot of photographs too. However, bad thing, it's only one person's view. It is a biased opinion on what you want to focus on within the photo. Our results then, radar graph. Noise consistently scored low, scoring only a 2 at all 3 sites. Shop exterior scored just a 2 at 2 sites and a 3 on 1 site. Ladies and gents, if you can't remember this, do not worry. What you need to just say is that consistently, just pick one of them, Greenery scored lower, consistently all three. Restaurants scored low, therefore people would not want to go to Barnsley Town Centre. There is lots of litter in Barnsley, we notice this at all three sites, therefore this deters people from the area and Barnsley needs to be regenerated. Same with the photographs. There was a lack of greenery in all three photographs. We can see litter in all three photographs. We can see the shop exterior is poor in all three photographs, deterring people from the area, meaning that Barnsley needs regenerating. Linking them together, well, it works, doesn't it? We can quite clearly see it. There's litter evident on our radar graph at all three, and there was litter evident in all three photographs. There was lack of greenery in all three sites, according to our bipolar survey in the presentation of our radar graph. And there was a lack of greenery in all three photographs that we can quite clearly see. What was the conclusion then? Conclusion, dead straightforward. It has a poor quality environment that's in need of regeneration. We can identify this from the results of both pieces of our data. However, our conclusion could be strengthened by carrying out further data collection methods, i.e. conducting the bipolar survey more times to improve the validity of our results. Why might have we produced unreliable results for our human fieldwork? Well, this was entirely your opinion. If you were determining noise at site 1, what you thought was noisy, I might have only thought was pretty, about in the middle, or vice versa. Maybe you didn't see any restaurants, so scored it 1, but I actually saw a cafe and I count a cafe as a restaurant, so I scored it 2. The bad thing is here, we produce inaccurate results, therefore it is bias based on one person's opinion. We didn't determine what does 1 mean, what does 2 mean, what does 3 mean, what does 4 mean, or what does 5 mean. So that's how we could improve it. We could agree on what was noisy and what was quiet before we went out. What might have been inaccurate about measuring this? Imagine if you didn't have access to a phone camera. Imagine if you went up to a shop front, one shop front which was really, really ugly, but the other shop fronts next to it were actually decent, but you only captured that in your photograph. You took a biased photo. How to improve it? Well, we could have taken panoramic photographs to get a much more larger area. Therefore, it's going to be more fair, isn't it? Summarising, ladies and gents. Your physical fieldwork question is, assess whether hard engineering methods have been successful in protecting the coastline at Mappleton. Your human question is, does Barnsley need to be regenerated? On the board now is the summary which I spoke about at the start of the lesson. What you need to be aware of is the common mistakes people make is that the question might say, how effective are your collection methods? And they'll end up talking about this. Or vice versa. The question might say, how effective were your presentation methods? But they'll end up talking about this. You need to make sure, if it says presentation, you're talking about presentation. If it says collection, you're talking about collection. Moving forward, for the rest of the evening now, if you have a spare 15 minutes, half an hour, my advice on your own now would be, look at this and memorise it. Make sure you are aware of what our presentation techniques were, our collection techniques on both studies, what our conclusion results were, and our evaluation. And remember, you can flick back through this presentation to look specifically at what the evaluative methods were, why taking photographs is good, why the cliff height graph was good, why the cliff height graph was bad. You can also look at those example answers in a little bit more detail as well. Tomorrow's exam, it's got 2 sections. The first section is on the issue evaluation, the pre-release. We did go through that today for about an hour and a half with some of you. We will happily go through some of this again tomorrow with you if you come between 8 and 8:30 tomorrow morning. that entire document you are going to be given a fresh colour copy in the exam, which you will use. Come to us tomorrow morning, we can go through that 9 marker if you feel slightly unsure about any of it. The second part of the paper is section B, the fieldwork. That's going to be on Mappleton and Barnsley. There's also going to be a few unfamiliar fieldwork questions in there, like we mentioned previously also. Before we finish, I'm just going to look at the back of the room and see, is there any questions that have come through? No?
Final call?
Yeah, final call. There's a quick reminder on there. If you've got any questions, please send them through now before we finish for the evening. It says there, reminder, JMI and YSTR will be available from 8 a.m. I should say 8 a.m. In their classrooms. Just wait a minute or so to see if anyone else doesn't look like anything's coming through. Thank you for tuning in. Final from me, the usual. Don't stress, do your best, and forget the rest.